First type of semiconductor is intrinsic semiconductor. The next type of semiconductor is extrinsic semiconductors. What are these extrinsic semiconductors? Are where some impurities are added. When adding an impurity to intrinsic semiconductor, it turns into extrinsic semiconductor. So I am adding some impurity. That process is what is called as doping. The process by which the impurities are added is what is called as doping, and that particular material whatever it is added is what is called as dopant. So based on the dopant only, now it is going to get subdivided into whether it is N type or P type. But these impurities are added 100 parts per million. What's the meaning of that is, for 1 million of silicon atom, I will be adding it to be 100 parts. If I take phosphorus, 100 phosphorus atoms are added to 1 million atoms of silicon. Okay, children, all understood what is doping and dopant? Dopant is that particular material used. Doping is that process of adding, so that you can turn that into extrinsic semiconductor. So based on the dopant, there are two types, which is of N type and P type. First, understand N type so that when you learn P type, when you compare and learn, it will be easier for you. Okay. So today we are going to learn only N type. When you are thorough with N type, then we will move on to P type. So N type semiconductors itself says N. What is N? Always negative, which produces negative electrons. So in this type of semiconductors, you will have more number of electrons, so that it will be called as N type. Remember this. So here we know that always you are going to have germanium or silicon, which is going to have valency as 4. That is, silicon will have 4 as valency. And here when I take a dopant, which is going to be a pentavalent, that is phosphorus, which have 5 electrons. Please don't confuse yourself, penta, so P type, it's not so. Pentavalent says that I am going to take 5 electrons in the valence band. So what happens? This 4 electrons are going to form the covalent bond with the silicon. But already one free electron exists, which is loosely packed, which can start moving when the energy is applied. That is, these free electrons are found near the conduction band. So it is very easy that when you have supplied an energy, what happens? The temperature increases, and immediately all these electrons can enter into the conduction band and it can start conducting. So this level is what is called as donor level. So these electrons are found just below the conduction band. These energy levels are called as donor energy levels. When an external field is applied, what will happen? All these electrons from the valence band will start conducting. So actually we have studied that energy required for germanium before that was 1.1 electron volt, isn't it? But now it is only 0.01 electron volt which is required. This is why we are using an extrinsic semiconductor. Just by adding an impurity, it reduces the amount of energy required to start conducting. So this donor impurity, these phosphorus, what are these called as donor impurity? Because it donates an free electron. So hence, as it is said as N type, naturally number of electrons is greater than number of holes, because when the free electron starts moving, it creates a vacancy, holes are there, but always this number of electrons will be more than the number of holes. But here again current is produced due to electrons and also due to holes. So I will call here majority carriers as electron. Why? Because more number of electrons are found. So majority carriers are electrons in N type and minority carriers are holes in N type. So Can you understand why it is called as N-type semiconductor? Learn this very well, so that in the next class I will teach you about how it is P-type semiconductors are called. Okay.